Hello everyone, good evening, good afternoon, and another namaskaram. So here I present you LearnOps by Amanpreet, and hopefully you have been watching my first two videos where I introduce myself and talk about the journey where we want to start with. How do we start with the from intern level to the corporate level, and we have been covering Git and GitHub approaches in the last two videos and talking about the types of positions and types of position available in corporate sector level. So from here we will be continuing about the course studies. So my four pillars are DevOps, system architecture, cloud strategy, infrastructure engineering. So we will be focusing on these areas, trying to learn as much as can possible. I will try to express more into these areas and about to start Docker, Jenkins, and Linux with DevOps. This must be a basic pillar for all of you to understand the structure, and thereafter we can go further with um, Docker with some 10 videos that will help you to understand the basic knowledge, and some 10 videos with Jenkins, and some videos with the Linux administrations. So this will add up as a pillar for interns, and slow more we will add with some projects. While projects will be deciding our goal for learning that my goal is to give you a best possible practical knowledge on the project sites. So let's begin with the Docker, and hopefully you will learn a lot from my videos, and definitely you will get some experience on what we have working through. So let's begin with our videos, and let's start with a good luck. Hope everyone would join us and everyone have happy learning. So let's build the PPT I prepared for you. Um, Introduction to Docker. Docker is a container platform where you package your app plus dependencies together and run it anywhere. So basically, Docker is a container technology where you can run package apps and its dependencies and run it anywhere. So initially in the traditional old method, what happens is you install your packages, you install your Nginx server, let apt install Nginx, app install Python, Node.js, or your Java application dependencies, and then you try to code into your environment, and then you try to place into the where directory, and that where directory will be placed into the Nginx, and Nginx will run your application, whether in Tomcat or Nginx or IIS application, depending on the operating system. But now, as we have Docker technology, we are compressed in one image, one recipe, and good to go with one click, that is Docker build or Docker run. Next is why traditional method fail and Docker been coming the picture into the system since 2002. So traditional method problem fails because machine in developer machine like this machine, your Mac OS, your Windows, your Linux, that is your local machine, local where you are actually workspaces. That is different from your production server. Suppose you have installed some application, some app like some web e-commerce app, and that is running with the Node V18 and MongoDB and Linux as an user operating system. And in production, you're working with a different OS. Like in developer machine, you're seeing it is Red Hat 8, and in production server, you're seeing Red Hat 9. So no, so this is the mismatch kind of mismatch happening between the developer machine and the production machine. So that is resolved with the Docker container. So you get faster services faster reliability, site reliabilities, faster uptime, faster user interface. So these are the things that we achieve by Docker container. We first of all Docker container installed in on top on host machine with whether it is Windows, Windows or Mac OS or Linux. On those host machine you need to install. Again, then on top of that environmental configurations, on top of that libraries and dependencies, on top of that run time, Node, Python, Java, whatever the languages you are dealing with in your project, and on top of that you are running your application code. So Docker architecture is very simple. You have only two things, that is Docker client and Docker daemon. And from Docker client to Docker daemon, till you are pushing it to Docker registry is one type of flow. So CI/CD with Docker, developers take the code, feature it, and push it to GitHub. From GitHub, it fetches to CI pipeline. From CI pipeline, it fetches to build Docker image, then it fetches to push to registry. From that registry, the image is picked up and container is run, and you monitor your application with the depending on the tools you have, Splunk, Grafana, or cloud monitoring. And with the Docker and Kubernetes flow, what is happening here is you take the image from the registry, you make the Docker image, you and Docker image is pushed to Docker registry, and from Docker registry, the Kubernetes cluster fetch the images, and it containerize it and orchestrate, and then it make into the user access app. Problem with Docker was that it resolved the Docker machines issue that and fails on server. That is the main thing. And environmental mismatch problem. These three problems which you see on the screen, it solves you that. What is container? As we say that container is a lightweight, isolated environment. Shares the host on OS kernel start in seconds. Which virtual machine versus the host Docker. Virtual machines is nothing but full operating system where your apps are running. But in Docker, you share the host kernel and then your app starts it running, and then this is called lightweight. So one server, one application is applicable, but in Docker, one one kernel on top of that Docker, on top of that, many applications are applicable. Flow diagrams are like Docker's client, Docker daemon, Docker image, Docker container. These are the simple architecture view that I showed into the Docker architecture. And blueprint is your recipe into the code. The application recipe into the code is there in the Docker file, and with the Docker dependency. It is an read-only template. You can just read the template once it become a image. You cannot write it. You cannot write the image, overwrite the image. And only the thing you do is while preparing the Docker file, you need to be very cautious about when, and that becomes your Docker image. Running the container, once the image is created, it turns out into a container, a running instance, and an isolated process, and can be started or stopped. So this is the Docker architecture. The Docker client, Docker daemon, and Docker registry depending upon request via API it runs. So build the image, run the container, manage the resources. Docker build will give you Docker will when you type Docker build, the client sends the request to Docker daemon, and Docker daemon creates an image. Similarly, when you type Docker run, the client sends Docker client sends the request to Docker daemon, and Docker daemon launches a container. So here are the commands in Docker networks and Docker volumes, and they are the common Docker commands in real web plus data pages where you learn where you have network like reach, host, and macmillan, and we have volume that is attached to the local to the data. Docker command, these are the Docker commands that we use day to day, and this is the web plus database commands that we create by one is the Nginx application, second is the database application. So this is the Docker file from that is from image. Image is nothing here is node colon 18, that is your image. You can find it in GitHub, sorry, in Docker registry also. And work directory where it is the workspace where your code has been um, fetched from localhost workspace. And copy is a command you copy all your codes from local directory to your current working directory of slash app. And run is the dependable command that you run it. That npm install is a dependency, and run command install your all your dependency into the image. That is the use of run command. And cmd is the command where you run all your applications in one go. That is the ever 24 hour into 7 running phase command. So it cannot get existed once you until you stop the container. So these are the Docker commands and sheet. So here what we have to understand in project or in corporate cycles, where we have to very conscious about the some of the sudden commands like run, rm, rmi. So these are the commands where we need to very consciously work. We have to take the permissions of our leads and technical managers whether we we can to stop rm or mri some images or containers. So here we need to be taken care very carefully. So wherever the RM deals with, we need to take it very clearly. Docker container builds container, Kubernetes manages the containers, handles the scaling and self-healing CI/CD pipeline with Docker. So here is the CI/CD with Docker. And as you go through from developer stage to git push to CI pipeline, get to images, push registry, deploy to the last at server. So Docker container runs the container port with that particular existing with the host kernel, and you have rm command and docker ps for listing all running containers. Rm for remove a container. Summary: you take container as a platform, image as a blueprint, container equal to running app used in DevOps and cloud. So guys, this is a quick understanding of Docker. In next few videos, we will be dealing it practically, pull push of the Docker, and how do we relate with real scenarios using Visual Studio to pushing into the GitHub, pushing it to the production servers, and mismatch of the servers between the traditional and the current modern DevOps technology. We will be seeing that in the next video. So take care. Happy learning, happy learners. Like, subscribe.